Today we're going to look at an introduction to parabolas. Very first thing we see here is what's called a parent function. Parent function just means nothing has been added or subtracted or multiplied to our function, y equals x squared. It's in its most basic form. The graph that's on your notes here would be the most basic graph of a parabola, y equals x squared. What we're going to do is we're going to look at different parts of it. We're going to talk about the vertex and the axis of symmetry and how we can find all of these parts. X-intercepts, y-intercepts. We're going to look at these with a few different forms, or in a couple different forms. The first one being standard form. You'll see that the standard form is ax squared plus bx plus c. We're also going to look at something called the vertex form, and we'll do that in a minute. Vertex, let's talk about what a vertex is first. Vertex is what we call the min or the max of the parabola. What that means is if the parabola is opening up, the vertex is the minimum point, it's the lowest point. If the parabola is opening down, the vertex is the highest point, it's the maximum point of the parabola. If we're looking at the standard form, ax squared plus bx plus c, we're going to have to use a little formula. X equals negative b over 2a. And that's how we're going to find the x-coordinate of our vertex. Once we figure out what that is, we're going to plug it back in to the equation to find the y-coordinate. Alright, and we'll practice that in a little bit. If you look at this other form, it's called vertex form, you'll see a couple new letters here, a couple different letters. Maybe you've seen them before. This is a nice form to find the vertex because you don't have to do any work. You just look at the h and the k, and you'll write them as the point h, comma, k, which is the same as just an xy. The only thing that you really want to note here is that the h value is always the opposite of what it looks like. So if you were to have the formula, for example, y equals x minus 3 squared plus 2, your vertex is actually going to be positive 3, positive 2. So that h value is always the opposite of what it looks like. And again, we'll practice that. Moving on, we're going to take a look at the a value. Alright, so the a value, if it's in standard form, the a is in front of x squared. In vertex form, the a is usually out in front of the parentheses there. Or it will be out in front of the parentheses. So the a value. The a value is going to kind of give us the shape of the parabola. So, first of all, if you look, a is greater than 0. Remember, that just means that a is positive. Numbers bigger than 0 are positive. If that's true, if that number is positive, the parabola is going to open up. So it'll be this general shape. If a is less than 0, or if a is negative, then the parabola will open down. Usually it's pretty easy to remember. Maybe some people would think positive people smile, so you would smile here. Negative people frown, so that would be like a frowny face. They're depressing. But if a is positive, it opens up, negative, it opens down. Another kind of cool thing that a tells us is if the graph is going to be wide or narrow. So narrow would be really skinny like this, where wide would be really open like that. So if the absolute value of a is greater than 1, meaning if a is bigger than 1, and again, we don't care if it's positive or negative, that's what that absolute value means there. So if the number is bigger than 1, if it's a 2 or a 5 or a 5/2, it could even be a fraction like that, then the graph is going to be really skinny, it's going to be narrow. If the absolute value of a is less than 1, so if it's smaller than 1, again, I don't care if it's positive or negative, this just means it's like 1/2 or 1/3 or 2/5. Usually it's going to be a fraction like that. Then the graph is going to be wide. One way to kind of remember this too is to say if it's a fraction, it's a fat graph. So fraction equals fat, wide. Alright, axis of symmetry. The axis of symmetry is the imaginary line in the center of the parabola that divides it in half. It actually, if you look at a parabola here, if I just draw a parabola, the vertex is right in the middle. The axis of symmetry is always going to go right through that vertex. The way we find the axis of symmetry is by using an equation, x equals negative b over 2a. Does that look familiar? It should, because that's how we find the x value of the vertex, which makes sense because the vertex, the axis of symmetry goes right through the vertex. Make sure you're really careful when you're doing this. It's an equation, it's a line, it's an imaginary line. So if you don't put x equals, you're going to get it wrong. So that's one really important thing, and I'll keep focusing on that in class. But axis of symmetry is always a line, x equals. Alright, min or max value. I talked about this a little bit, but the min or max value is actually a number. So that word value there means I just want one number. So that's always going to be the y value of the vertex. It might be something kind of important to write down. The value is the y of the vertex. So if I ever ask for value, you're going to give me the y from the vertex. Alright, so if the parabola opens up, again, just draw a picture. If it opens up, look to see where the vertex is. It's down at the bottom. It has a minimum. If it opens down, so just sketch a picture opening down, then the vertex is up at the top and it has a maximum. Alright, last thing we're going to look at here is the y-intercept. The y-intercept is where it crosses the y-axis. So, the way you're going to do this, you think about a graph, the y-axis, any point on the y-axis, what's true about the x value? The x value is 0. So, you're going to substitute 0 into the equation for x, and then you're going to answer it in the form of x is 0, and then whatever you got for y. Alright, one more form that we're going to take a look at here is called the intercept form. Intercept form, as its name implies, it's going to help you find the x-intercepts. So if I look at a graph here, and here's my graph, if I just sketch a graph of a parabola, it doesn't matter. This is going to help us find where the parabola crosses the x-axis. So you'll see that there's a p and a q here. Actually, I'm going to call this x minus p and x minus q. Those are each a factor. So there's one factor, here's another factor. Alright, just like we did before, this is going to be review the a value. So I'm going to go quick here. If it's greater than 0, if it's positive, it opens up, just like it did before. If a is less than 0, if it's negative, the parabola opens down. Looks like that. If the absolute value of a is greater than 1, it's going to be narrow. If the absolute value of a is less than 1, then it's going to be wide. Remember, fat fraction? Or fraction means it's going to be a fat graph. Alright, and again, that's just compared to a basic parent function. Alright, here's our new stuff. X-intercepts. The way we're going to find the x-intercepts is we're going to solve each of the factors. So that's why I had you label that up at the top. We're going to solve each of the factors for x. We're going to write each x-intercept as an ordered pair. So what I would do here is I would say, okay, I'm going to go back to my x minus p. I would do x minus p is equal to 0. Add p to both sides. We get x is equal to p. If I did x minus q equals 0, I'm going to get that x is equal to q. But then, of course, I want you to write those as ordered pairs, so it would be p, comma, 0 and q, comma, 0. Those would be my ordered pairs. Axis of symmetry. Again, that's just the line that's going to cut it in half. So, if you look, if this is my x-intercept and this is my x-intercept right here. Where is the axis symmetry going to be? It should be right smack dab in the middle of those. So, axis symmetry is the imaginary line in the center of the parabola that divides it in half. The way we're going to find this, so pretend like this was point P and this is point Q. Those are those x-intercepts. If this line is right in the middle, you're going to use the equation P plus Q divided by 2 to figure out where it is. Remember, it's a line, so a line is always x equals whatever our answer is. X equals P plus Q over 2. Vertex. How are we going to find the vertex for this format? The way we're going to do this, again, the vertex, remember, is just the min or the max of the parabola. So it's going to depend on which way it opens. The vertex is always going to be on the axis of symmetry, so my vertex is going to be right there. So we use that same formula, x equals P plus Q over 2, to find the x-coordinate. Plug it back into the equation to find the y-coordinate. And again, we're going to practice some of these. Same as before, min value or max value. Remember, that's just the y value of the vertex. If the parabola opens up, if it looks like this, it's going to be a min, it's going to have a minimum, and if it opens up, or sorry, if it opens down, it's going to have a maximum value. And remember, you're looking at the y value of the vertex. If you want the y-intercept, you need to substitute 0 into the equation for x and answer it into the format x is 0 and whatever you got for y. Alright, let's try some of these.